So I think we can start. By this time, considering the delay, you may be watching this at the time that we have scheduled. I don't want to take much of your time, so let's try to be quick. And the ones that have questions, we have by the side of this video, we have a place where you can a chat where you can put your questions, your comments, your suggestions. Please don't hesitate to do it. This will help us improving what is being offered. And in case, if you're new in this YouTube transmission, online transmission, don't worry in case your connection drops or if you have troubles, because YouTube takes care of it. It will restart when you get your connection back. It will restart from the point that it has stopped. And you also have on YouTube the possibility of decreasing the size of the video in the bottom right, and you can, if you have many problems, you can decrease the quality and watch this without problems. So please leave your comments, your questions, and afterwards I hope to go through most of them as possible. And this is going to be recorded and saved, and you can watch again afterwards. You can mention to other people that want to have access to the same information. So let's go straight to the objective here, which is to do the demonstration of SimSched Pit Optimizer. This is our objective. You all are from the industry. You know that it's a fair amount of money in order to buy a license of Pit Optimizer from different brands that we have available. And what we are offering here for free is something that works really well. It works with the high standards of the optimization that's used in the research centers on mine planning in the world, where it's not discussed anymore lerchs-grossmann. We discuss methods based on mixed integer programming with the use of heuristics to accelerate the process. And this is the framework that most of the research centers are using, the published papers, and what we're bringing here to the industry is just we're just converting to commercial packets ideas and techniques that were well discussed previously in academy. So what we have for free is something that really works, and if you have any doubt, you can go through our website. You see here miningmath.com/software. You have here the second paper is in English. It was presented in a Brazilian Congress of Surface Mine, and it talks about this comparison, this technical comparison of the algorithm that SimSched uses against lerchs-grossmann. In this case, we use Whittle, and we compare the consequences of using our method versus lerchs-grossmann. There are pros and cons, and I'm not going to go into this. It's not objective of the presentation here. So we can move on the objective, which is the demonstration. I'd like to thank you, Alexander Boucher, which is the owner of R2 Tech, is the company that currently develops the SSPO software, because we are developing SimSched inside SSPO. SSPO is a free software. It was originally developed in Stanford University, and now R2 Tech keep developing the software, but it is still free, and it's a software for geostatistics, simulations, and things like that, statistics. And the first version of SimSched, both the Pit Optimization and the direct block scheduler, are going to run through SSPO. What you're going to see here is the software 98% ready. So we have a few things that we still have to fix, few things we're going to change, but you can see most of them ready, and that's what you're going to receive later. We have here, this is the screen of SGEMS, and we have the plugin of MineMath here, the Pit Optimizer, and you just have to run the algorithm over this option here. And so here is the plugin of SimSched Pit Optimizer. I'm going to go through the basic steps, which is I need to import a model, a block model. I'm going to define a name for this project, and it's going to be saved over there. Some statistics of the model. Here is how we define what's the meaning of each column of the CSV file. And actually, I have already put the right names in the header, so the software already understands the meaning of each column. But if I hadn't, I could change and select the meaning of each column. I could import indexes in X, Y, and Z, grade values, economic value for the block, many different economic values, recoveries, densities, block by block, slope angles, and anything else that the algorithm is not going to use, but you can import together with your data. So here we are actually importing the data. We have already read through the data the dimensions of the model, and we have just to complete the information that's missing here. So we just the variables, the unit is the block dimensions, and you saw that if something is missing, I cannot go ahead. I cannot go to the next steps. The interface helps me to go through all the steps. So as I have imported, I want just to see the model and see if this has been properly imported. So it came back to SGEMS, and you see here the model that was imported. I can select to show just the blocks below the topography. So in case you have, you can do many things in SGEMS, like plotting section views, plan views, doing statistics, but it's not the objective of this presentation. So let's go ahead. The model was okay, was imported here with grades. Let's come back to SGEMS. I have my project here already imported with information, with details of the content of this project. And we can go to the pit optimization process. And you see here that we have the two modes, the direct block scheduling, the pit optimization, and direct block scheduling is not available for the free version. It is going to be, this software with direct block scheduling is going to be released next year. And just one important note is that the pit optimization is just a direct block scheduling with one period. So if I'm not doing a scheduling, I'm just scheduling one single period without any discount rate, I have a pit optimization process. So this is a simplification of the whole algorithm that we are going to release next year. Therefore, that's why we're giving this for free, and this makes sense. We're not having more work to do specifically for developing a tool for pit optimization. And this is how we're going to progress. Everything we add to the direct block scheduling tool, we are going to make it available for free on the pit optimization version, because it's not taking us more time to develop specifically this software. This is the current policy of the company, and I'm going to talk about it later. Let's keep going. I have imported a field in the block model with the densities. So I have block by block a different density. I'll put a value here as a default in case there's missing values in the file imported. I have a default value. I don't have, imported the slope angles in my CSV file. So I'm going just to define a constant, in this example, 45 degrees. The remaining parameters here are related to the scheduler. They don't make sense in when you're discussing pit optimization. Same way, you see that if a field is missing anywhere, I cannot go ahead with the next steps of the algorithm. So let's go to the destinations. I have to inform unlimited number of possible destinations for the blocks. Could be a processing route, and could be a waste dumps. So I could include many here. And in this example, we have just one process and one waste dump. For the process, I'm going to select here the recoveries. I have imported the recoveries block by block for this process. And the important field here is the economic value of the blocks. And this is an important concept. The meaning is, I have in my file a column that defined the economic value of the blocks, given that I send the block to the process. And I have another column that gives me the economic value of the block, given that I send this to the waste dump. And the algorithm is going to decide where to send the block to. It's not the user doesn't have to predefine this. You just plug the possible economic values and the algorithm do this for you. So we can go to the constraints. Most of them are not available because they are related to the scheduler. But a very, very important constraint here is the minimum bottom width of the pit, the ultimate pit. And I want to select, for example, 100 meters. I want to my ultimate pit to have 100 meters width, and the algorithm is going to run the pit optimization considering this constraint, which is different from what usually is done. When you have the lerchs-grossmann algorithm, it's not possible to inform a minimum width. When you do this in mining software packages, what they are doing is they are running lerchs-grossmann, and afterwards they're cutting the bottom of the pit until you have in this example, 100 meters of mining width in the bottom. So it's not that the optimization is choosing the optimal pit considering this minimum width. So there is a difference here. I'm going to show an example afterwards. So that's it. We have everything here. It's just an overview. If you are an advanced user, you could have skipped all the first steps. You could come straight to this screen and fill up the blanks to run the algorithm. I could save scenarios. So if I want to change some parameters, I want to change economic scenarios, and I want to run different possible ultimate pits, I could do it and save the configuration, but I'm going just to run. So that's it. It's done. It automatically generates Excel spreadsheet with the results for each possible destination. We have here the tonnage of material sent to there, the average grade, and the quantity of metal produced. The first version of SimSched Pit Optimizer is going to report just one variable, but afterwards you're going to generalize to multiple variables too. So you see for the process, for the waste dump, what is being produced, and finally the undiscounted cash flow, which is what we are maximizing in this algorithm. In terms of visualization, we have here the result, and you see I'm selecting just the mined blocks, and I'm seeing the colors according to the destination that the block was sent to. You see the order 1 in the order that I fill up the form. 1 is the process, 2 is the waste dump. So the blue are the blocks being processed, and the red, the blocks being sent to the waste dump. And you see that the bottom is respecting the area that I requested. I asked for 100 meters, and we are here respecting this in the bottom of the pit. And we have, actually, those blocks are just a consequence of the surface. This is the surface. Sorry, this version of SJames doesn't have yet the triangularization of the points, but we're going to work on this later on. So you see the surface that was optimized, and the blocks are consequence of the surface. We check the centroids that are above the surface to define which blocks are going to be mined. And we have here the topography, if you want to see the difference. What I want to show you is one example here. That means, let's do something else. If I get the same project and I change to 300 meters, for example, and we run again. Let's see what happens. So it's ready. We see the new results considering the 300 meters of bottom width. And the interesting part is, we see here that the new results, I'm just going to close the old ones, and I'm still showing the last ultimate pit with 100 meters bottom width, and I'm going to load the new solution. So you see here that the new solution has a bottom width, a larger bottom width that respects the 300 meters that was asked for the user. But you notice that as you give a new constraint, a new restriction to your optimization, the algorithm decided that it was not worth it to go through this wall anymore. It decided to stop mining in this point with the 300 meters bottom width, and not to go deeper, and not to mine this wall. So this proves that we're not simply running an algorithm like lerchs-grossmann and cutting the bottom of the pit. We are actually running the optimization considering another constraint, and this is the optimal pit, considering that I want to respect a bottom width of 300 meters. So what you see here is absolutely, from what I know, absolutely doesn't exist. If you're looking for a software that does this, and we're giving this for free. This works, this is useful, this is in accordance with the academic developments with mixed integer programming plus some heuristics to accelerate the process. And we intend to keep developing as the direct block scheduler keeps developing with new tools. We're going to bring them, the ones that make sense, obviously, to the free version at the same time. We're going to release. And for example, once we include blending constraints in the direct block scheduler, we could come and bring this to the pit optimization too. So it doesn't exist a software that does pit optimization and consider blending constraints at the same time. So the user will just import the block values for each possible destination, the grades, and mention what would be the possible combinations of blending that he wants. And the result of the algorithm will be like you're seeing here. which blocks to mine, where to send those blocks, respecting operational parameters like this, respecting blending constraints like I mentioned as an example. So it's just an example of new constraints that will be added in the future. And if you haven't yet, if you're just watching this presentation, but you haven't yet sign up for your license, please enter simsched.com and you could sign up with your email here, and you're going to have access to a free license of what I'm just presenting to you. This license is valid for 6 months, and the current policy of the company allows you to renew this license after 6 months and so on. But this is the current policy. We cannot guarantee that in some months or years, this policy could change and you are not going to have the license anymore once this expires. But if you refer this software for other people, we see here if you refer to 10 or more people, your license is going to be valid through your lifetime. So it will never expire. So we ask you to refer the software. It's a way to help us. We're helping you, giving you free software. So why not helping us to share this idea? And you're going to have an interesting benefit of having this forever, this software forever, and you can use freely for any purpose. We are currently close to 1,000 people registered to receive this license, and we hope to achieve higher numbers later on. So I'd like to thank you for this time, your time with us. We hope to be contributing to your mining project, your mining operation, to your consulting business, your academic research, or if you're a student, your learning process, your students, you're giving this in classes for students. We hope to be contributing to the industry with this free software. We're going to provide free tutorials, some help files to explain how to do things, videos with short demonstration of specific things that the software could do. And we are building a network of representatives. We have already set up an agreement in Australia, in Peru. We're discussing very advanced in Finland. We have other people in Europe, in Asia, in Africa, in America that are discussing ways to be representative of the software. Here is the free version, and these people will be ready to do the training in case your team needs. And you are seeing this with this demonstration that you actually could have more than you could have this training online. We could also teach your team, but we want to have people closer to you to help you as you need. Of course, the free software doesn't have free support. So if in case you want to have your team well supported to use this tool, we can provide to you support. We will have a rate for that, and we're going to give this information later on, and you will be able to give support to your team. It's an option. Instead of buying licenses, you spend some money with support for your team to use this free software. So thank you. I want to see if in case there are other questions. The online demo is done. If you are in a hurry, thank you for your time. I'm just going to look through the questions if you have any questions in the chat. And we have one from John. He wants to know if this presentation is going to be available afterwards. So the answer is yes. We're going to keep this presentation saved, and you are able to watch this afterwards and to refer to other people, and they will see how the software works. Just remind that this is not the software ready. This is a software almost ready. So something that you're seeing here are going to be slightly different when we release the product. We have another question from Derek. How can this be added to stratified deposits such as coal? Derek, the limitations of the software, we work with regular blocks. So you need to model this into regular blocks, not sub-blocks, not percent models. You need regular blocks. But actually, we have tested this up to, as I mentioned, 240 million blocks. So if you have a deposit that you need more detail, you could include blocks, smaller blocks with more details on different rock types and things that you may want to add, to include details. So you need to make this into a regular block model in order to run the SimSched product. This is the current version. Of course, we can discuss possible evolutions of the software afterwards, and I'm keen to hear from you. If you could send me an email with ideas afterwards, we can discuss. Have another question from Volker Osterholt. How does the block size interact with the slope angle? Partial block reporting. Okay. The optimization, if you could later read the paper that if you could access here and read this paper, the second one, it talks a little bit about how the algorithm works. And what we do is we optimize surfaces, because if you are a researcher, if you have ever written an algorithm like this, what usually is done is a set of block predecessors. So if I want to mine a block down here, I need to mine a given set of blocks above it. And what we do here, we work with surfaces. So I have to take care of slope angles given the pair of those adjacent cells that you see here. So this is how we control slope angles. And the block, if the block is inside or outside this surface, this is what we are reporting here. We check if the centroid of the block is above the surface. If it is above the surface, it is inside this report that SimSched is giving here. But if you want to have a more detailed report, cutting blocks with exactly where the surface is passing through, these results here are automatically, I didn't show to you, but these results, if I come to the project folder, both the mine blocks and the Optmization pit, the surface, are automatically exported here into CSV files. So you can have this surface, which is just a grid with X, Y, and Z. You can import anywhere else, and you can calculate to the level of detail that you want, separating rock types or any kind of thing that you may want to do with a general mining package of your preference.